Here is video number 2 for this week. What are we talking about, Jared?
So we decided we've been talking a lot about JavaScript, the language, but we've been really thinking hard on how we would like to teach somebody, not about so much about the language specifics, but how to think well, how to think like a good programmer. Or as I would say, not a programmer, but a software engineer.
Yeah, you can know every little detail about JavaScript and still be a rotten programmer.
So why is that? Why can you be rotten?
Because programming isn't really about knowing a language, just like writing a book isn't about knowing English. It's about being able to digest a problem and break it down into smaller problems and solve those problems one by one. It's about understanding the essence of a challenge, and well, that sounds really
Deep. That was really good.
yeah.
The
It's about
essence of the
understanding the
challenge.
essence of the challenge.
That's going to be quoted everywhere.
And it is, and breaking it down into smaller and smaller pieces until you finally solved every little problem. It's like those JPEGs back on the internet in the olden days.
So where they'd go,
Wait.
you'd have something like this and you'd start up these big blocks, right?
Yeah, you had the first pass comes and you get like 12 blocks in a huge picture.
And then you have this come through, right?
And then it makes all these passes, and then each little pass finally until you get to the little pixels that you actually cared about. That's kind of how I view programming. And in order to do that, to organize your program well, you really need some tools. And so we're going to do a whole series of videos on these tools that you can just stick in your tool belt, and when you're programming, you'll say, I need the observer, and you go, here's your observer, and you'll write it out, and your life will be happy.
So in my career as a software engineer, the one thing that it's a friend of mine who's also a software engineer called me and said, this is our problem. And he's writing it in a different language than I write in most of the time, so it doesn't matter, but we're speaking abstractly to each other.
Mm-hmm.
And I remember telling him, he told me the problem, I go, I know of this, there's a design pattern that solves this, and I can't think of what it's called, and I went and got the book, and by the way, the book.
Yeah, speaking of design patterns.
This is the book, I'm not sure how close I have to get to it, but this book here is an amazing book. I actually got it not knowing when it was first written, but the first published date was crazy long ago.
This book's been around for a long time.
And what's amazing is these patterns are still really useful today.
So this book was written by a bunch of computer scientists who went through and identified, I don't even know how many.
Quite a few.
Anyway, there's a list of them. All of these design patterns that you can use to make sense of your problems. And
so that when my friend called, I ended up finding it. I just had to read the summary here. I was, it's the memento. That's what it is. And I said, go read about it and implement it. And so I didn't have to tell him how to write it. I didn't have to tell him anything.
Yeah.
I just simply said, this is what this is how to solve the problem, and go on your way. And this described more of the what, because it's how to handle it. How to handle it is language specific, so to speak. It could be.
Yeah.
But what we're going to talk about and focus on today is we govern ourselves, and the choices we make every day basically go along these two things.
So this is our first tool that we're giving you to put in your belt.
So we're not going to talk much about JavaScript. This has nothing to do with JavaScript. This could be applied to Java, C#. This is about being a good programmer or software engineer.
So our topic today, what and how.
So what does what mean? I remember. Let me take you back to a story, and we're going off the cuff again. A lot of times when I start engineering something, I do not think about the nitty-gritty details like Ben was saying. That's the last thing on my mind. The first thing on my mind is, how do I want to use this thing that needs to be invented? So I have a blank canvas. How do I want to write the code that just makes my life easier? So what I do is I start off with the what.
Okay, so let's look at it this way. Say I ran out of Sour Patch Kids, and I really need some more. So I'm going to say, Jared, go get Sour Patch Kids. The store is down there on the corner. Take Main Street, 2 miles, turn right, there's the store.
So you said some specific things. Take Main Street, turn right.
Actually, accidentally, that was good. The first thing I said was, Jared, go get Sour Patch Kids.
Right.
That is the big what.
There you go. So the big what is get Sour Patch Kids. Patch Kids, right? So there's our first thing.
That's the problem. Is I need Sour Patch Kids. The first level of understanding the solution is
I need to get some.
we gotta get Sour Patch Kids. Okay? Jared says, I don't know where to get them. I said, at the store down on the corner, take Main Street 2 miles, turn right, it's right there.
Well, we gotta slow down. So you said at the store. So at store, what do? I turn right.
To get to the store, yeah, you take Main Street.
Oh, to take Main. Oh, so to get to the store, you take Main Street. See, I already misunderstood your what. So take Main Street. So the first thing is take Main Street. And then what?
For 2 miles,
Okay. And then for 2 miles.
turn right.
So then we have next step is turn right.
And the store's right there.
Okay, so now we're at the store. Okay, right?
You've reached your destination.
So right here our big goal, but how do we get back?
Just do that backwards.
Turn left. Go 2 miles. We'll just say go. You can read that. Go 2 miles.
And then you should be back here.
Should be back. So this is, you've told me what I need to do, right?
Mhm.
One thing that I love about this, what is, you didn't tell me how. Because he just described something that, could I do this on my feet?
Yeah.
Could I do it on my hands? I
Maybe.
could. I could do it on a unicycle, a bicycle. I could do it in a car. I could do it in a truck. You didn't get so specific to me. You just told me what needs to be done. What
Right.
needs to be done, not how it's done.
So now I've told Jared what. Now it's up to him to implement the how. He'll get in his car or on his unicycle or gloves if you're gonna walk on your hands the whole way.
Uh-huh.
And you're gonna implement these instructions however you need to do it.
So this becomes then, this, so to speak, right here, becomes our interface. So now I, as a bicycle, I can come over here and say, hey, this is the bicycle. How do you spell bicycle?
B-I-C-Y-C-A.
Thank you. Bicycle. This is the bicycle way to get sour. So I'll say bicycle get Sour Patches, right? Now I just have to implement each of these what's, and I then fill in the middle. I fill in the guts.
Yeah.
So I describe the how now in here. We described the what, now I'm doing the how. You could come along later, right?
Mm-hmm.
And describe how a car gets to the store and back.
Yeah. So the overall point is, as the software architect, my first job is to figure out what the program does. This is the Get Sour Patch Kids program. This is the what. And then I don't have to worry about the how. We're gonna leave that alone for later.
What's amazing is you can actually engineer this way and fully know that it will work. Because didn't you describe what needs to be done?
Mm-hmm.
So this is going to give you Sour Patches, even though you didn't know the how.
Right.
This is the beauty of engineering. And on a full, abstract, far away, I talk to my friends, it's almost like an aerial view of the park. You know, a lot of times you're in the park, when you're down in the how so much, you kind of lose orientation. Like if you're in this really complicated park, you kind of go, where is that statue? It's somewhere over there. What you needed is a kind of a bigger map. That's what the whole map is for the pirates in the sea.
Right.
So they could understand where they were. They get lost in this big ocean. But the map allows them to see aerial, and that's what I would say the what is.
And as you're developing your program, it's kind of like a Google map. You're going to zoom in on each of these steps and then solve the problems inside that. Each of these becomes its own little program, its own little problem to solve.
So you're saying once we get to the store, we have to have more instructions, right? Because we have to go and find the aisle. So we find the aisle, we grab the Sour Patches, we go to the register, we get checked out, we go back to the car.
Right.
Or go back to something.
Yeah.
And that doesn't matter. That's just somewhere someone else thinks about that.
And even turn right. If you're a car, you're going to see grab the steering wheel, turn it clockwise, and all of this complicated stuff.
So you're saying that you can engineer something without knowing the whole how.
Yeah, and that's what you should do. You should never start with the what.
And we
If
tend
you-
to as programmers. Go
Yeah, we
ahead.
tend to because we're really details-oriented people, and we know that computers are stupid, and if we don't hold their hands the whole way, they're going to blow up in our faces. But what we need to do is step back and just start big and resolve in as we go, making things modular. If you start with the what, if you start at the how, you're going to end up with a really long, one very long source file that nobody can read and the computer itself barely understands.
And only does one thing.
Only, yes. If I were to describe the Get Sour Patch Kids program exactly the way I would be tempted to, then it is only good for getting Sour Patch Kids. I didn't teach the computer how to take Main Street. I didn't teach it how to turn right. I could reuse this stuff later.
Right.
But if it's all just one big thing, there's no reusability, there's no encapsulation, and it's a maintenance disaster.
One other thing that you realize when you have this what perspective, the aerial perspective, you start seeing patterns.
Yes.
And patterns emerge.
See, here's some patterns right there. We have a turn and a turn.
There you go.
So this is already something that maybe we could wrap up into a function with a parameter.
So already we've found when you start looking higher level, you start to see patterns because it's aerial perspective.
And the beautiful thing about this is like 20% of the program that I didn't have to write because I already wrote it here.
Right.
I
So
need to use it again.
so what you're saying is now we're consolidating these things into functions. So you're starting to see these bigger patterns. You're reusing code. Your code base actually gets less.
Mm-hmm.
And that is the beauty of engineering, is the fact that you can take lots of complications, simplify them, and then reuse them.
Yeah. So you want to go through a quick example?
Let's do it.
Okay, we're going to implement, just in pseudocode pretty much, Fibonacci generator.
So let's do pseudocode that kind of matches the C-style,
Yeah, we'll use curly braces.
maybe just like the function, function and parameters. But keep
Yeah.
in mind, if you're using Objective-C, sorry, you can do the message passing, which is really cool.
Fortunately, our whiteboard doesn't do any parsing at all, so it's not going to throw syntax errors on us.
Maybe I will.
Yeah, sure.
Error.
So let's do a Fibonacci sequence generator. A Fibonacci sequence is a sequence of numbers where every number is the sum of the last two.
Okay.
So we'll start big. It's a sequence of numbers. So we know we're dealing with numbers where every number is the sum of the last two. We got to start somewhere. So let's start with two numbers.
Okay.
N1 equals 0, N2 equals 1.
Okay.
Okay, now we gotta sum these things together. Let's see, to get the next one in the sequence, we're gonna go from number to number to number. So we're gonna have to get the next number at some point. So let's say get next N1, N2. And we're just gonna loop that over and over. Oh, but actually we want to output. So, output. Ooh, new. We'll do n new n equals get next, and then we'll output new n. Alright, so
Yep.
I'm stepping back, and we need to loop this over and over. So, let's say while n2 is less than 1,000, so there's a way
Okay.
out here. I hope this ends up being a good example.
Well, we're writing it as we go. This is like
N2.
discovery here.
1, n1, 0.
Okay.
And then we gotta shift the numbers down. N1 equals N2, N2 equals new N. Okay, there we go.
So you said, so we do the output, and then we actually do a reassignment. reassign numbers.
Yeah, the reassignment is,
Inside of get next, isn't it?
yeah, well, let's call that shift.
Okay.
And 1, 2, new, N. Okay,
So
So-
we'll say shift.
hopefully this is pretty clear. We're gonna start with two numbers, and then we'll loop over that for a while. We'll say our new number is get next N1 and N2. So this is a watt, there's no details in there.
Okay.
Then we're gonna output the new number, and then we're gonna shift them all.
Okay. That's
Then
all
we'll do
inside
it
the
again.
while loop.
Yeah.
This is implementation that's somewhere else, right?
Yeah.
Okay.
So I may not know how to do output, but that's okay.
Right.
I don't need to right now. I may not know the mechanics of the shifting, which in this case I admit is pretty obvious,
Right.
or how to get the next number in this sequence. Actually, you could, by abstracting it this way, you could, it doesn't have to be a Fibonacci sequence, you could do whatever you want and get next. But we'll do Fibonacci.
Right. That's actually a good point.
So all you have to do now, you'll have functions for all of these somewhere else. All you have to do now is go stub in these. Get next is really easy. You just add those two and return it. Output, if you might console log, you might
Might write it to a file.
printf, you might write it to a file. You might collect them all into a CSV and then upload them to Excel. You can do any of these with this, and then you shift them. That's going to be pretty easy too.
So that is how you solve a problem then. So we had a Fibonacci, it was described what we needed. We start with two numbers.
Mm-hmm.
We then add those two numbers together, right, to get the new number. Then we shift the values. Well, I guess we output, then we shift the values.
Yeah, so this is just we're gonna output it, and then we're gonna bump them down and do it again. What I like about this is that this is completely readable. There's no adding or subtracting or really assignment going on, except for that.
Before we did this video, we actually got in kind of an interesting conversation with our colleague. Just because I told him how today I had a problem where I realized that my code wasn't describing the what. And I really needed it to describe the what. And by not having it be descriptive, the next person that comes is confused because, for example, I had if any of you are jQuery, I had a jQuery and it said jQuery.show. But that doesn't make any sense. What's it showing? Okay, so let's say I named the element really smart. It was status. But that's still, okay, maybe you show the status. But I realized that what if later I needed to show the status was 2 or 3 steps? Then I'd all of a sudden have to put all that stuff. I was like, I should be descriptive. Even though it's one line of code, I'm going to put a what.
Yeah.
And everybody that comes and reads my code can just look at it, read it, and understand it.
Yeah. The other great thing about that is that you've consolidated all of the work on that status into one place.
Right.
So if you did have to show the status in 3 or 4 different places,
Mm-hmm.
then there's only, you call show status wherever you need to do that. There's no going and finding all of those places to say, oh, now showing status involves 3 elements, so I gotta stick all these elements in there.
You've consolidated, now you change it in one spot and it affected 3 areas, that's what you're saying.
Yeah.
Awesome.
Right here, it would be just as easy to say N1 plus N2, and this is what drove our coworker nuts.
Yes.
Is that, why would I not do this? Why would I choose the more verbose
Remember how we
function call?
and we described this earlier where, we could just say, let's walk the path of Fibonacci, right? That's
Right.
what this would be doing.
Yeah, this is only good for Fibonacci's. By saying get next, it reads better. It's more abstract and you can update that later. I'm of the opinion that with just a little training in the grammar of a language, a novice should be able to look at a program, at least the main loop of the program, and be able to tell what it's doing. Should just be able to read the operation of the program.
And if you can't, then we've done something wrong with the what. The aerial perspective is being confused with the hows.
We got how details leaking into the watts. So that's
think
the
that's-
gist of that, yeah.
I think what we should do is, so from here on out, we're probably going to make short videos. Maybe what we could do is describe lots of the patterns that we use
Mhm.
in these next videos and why they were useful to us. I mean, there's lots of patterns that we use currently to solve asynchrony problems, to solve observing patterns, like event-based systems.
Yeah.
We use these things daily, and there's reasons why we do, and we'll describe them in an abstract form. And that's what these series of videos will
We've
be.
even been wrapping patterns up inside of other patterns, and really is a lot of fun.
It is. It's what makes software engineering what it is.
Yeah, it's what I think makes it fun. Anyway,
I think that's it.
that's it for this week. Thanks for watching.
Thank you.